Kia ora Ben, Tosif and Snehal and anyone else who's watching who's planning on taking the AS exam. This video is going to go through a couple more trig and geometry questions. So hopefully guys you're seeing the same patterns are starting to come up over and over again. In question 6 we've again got a circle with some triangle-y stuff in it, and we've got all the detail about the diagram here. Right, so let's just start off by reading this one. The diagram shows us points A and B on a circle with the centre O and the radius R. The tangents to the circle at A and B meet at T. So as soon as you see the words tangent to a circle, you might as well mark in your right angles, because we know the tangent to a circle is perpendicular to the radius. That fact comes up in nearly every question like this. The shaded region is bounded by the minor arc AB and the lines AT and BT. And the angle at the centre there is 2 theta radians. First we have to show for 3 marks, which means it's not that bad. In the case where the area of the sector AOB is the same as the area of the shaded region, we have to show that tan theta is equal to 2 theta. So the strategy here is to work out the area of the sector, work out the area of the shaded region, and then equate them and end up showing that this is the case. Then the second part is to say that when we've got a specific value of r and we know the length of the arc is 19.2 centimetres, then we have to find the area of the shaded region. So that's not going to be too bad because we've already figured out the area of the shaded region back here. So what I'm going to do now is I'm going to draw a line on here to split this kite up into 2 triangles. Let's draw a nice line with a ruler. There we go. And I'm going to pick on one of those triangles. I'm going to do OAT. So OAT and OBT are identical triangles, and the angle here is going to be theta. Right, so here's A, and here's O, and here's T. This angle here is theta, and this is the radius here. We want to find the area of the shaded region. I'm going between these two because I want to be able to see both of them. So shaded area is going to be 2 times triangle OAT minus the area of the sector, which is r squared times total shaded area. So this area here, I'm just going to put sector. Right, what can I say about triangle OAT? Well, tan of theta is equal to length AT divided by r. So AT is equal to r tan theta. That means that the area of triangle OAT is equal to half the base r tan theta times r, which is 1/2 r squared tan theta. Now what about the area of the sector? Well, we know that the angle at the centre is not theta but 2 theta, and we've got radii here. So the area of sector OAB is equal to 1/2 r squared times the angle 2 theta, which is equal to r squared theta. So the shaded area is equal to 1/2 r squared tan theta times 2, because there are 2 identical triangles, minus r squared theta. That leaves us with r squared tan theta minus r squared theta. And we're asked to show that this is true when the area of the sector is equal to the area of the shaded region. So the sector area is r squared theta. So we've got r squared theta equals r squared tan theta minus r squared theta. We can divide everything through by r squared since it's a positive number, and that leaves me with 2 theta is equal to tan theta as required. So that's the first part done. The second part is pretty easy. We just have to find the area of the shaded region when we've got this value of r and this length of the minor arc AB. So all we're doing here is we're using my arc length formula, which is S is equal to r theta for the arc length. In our case, we've got the angle is 2 theta. So we have 19.2 is equal to 8 times 2 theta, which gives me theta is equal to 19.2 over 16, so 1.2. So theta is equal to 1.2. What is my shaded area going to be? So now we just have to substitute that in. Don't hang up the video. There's more exciting stuff coming in a couple of minutes. This is not as good as it gets. So r squared tan theta minus r squared theta, which equals 8 squared, so 64 into tan of 1.2 minus 1.2, which gives us 87.8 units squared. So there we go. That's, I think, a very, very easy 3 marks once you've got used to that style of question. Right, now let's look at this next one. This is an equation solving one, so a completely different part of your brain. You should be thinking straight away about drawing some trig graphs for these. We have to solve the equation 2 cos x plus 3 sine x is equal to 0, and it's for specific values. So 2 cos x equals negative 3 sine x. I'm looking at that and straight away I'm thinking there's no Pythagoras formula in here, which is one of the trig things we do in AS, but there is the other one, which is that sine x over cos x is equal to tan x. So always be on the lookout for places that you can use that. And in this case, what do we get? Well, we are going to divide things through. Sorry, I'm just trying to find my working before I get to the trig part. Let's see. What have I got? Sine x over cos x is equal to 2 over negative 3, so negative 2/3. I'm trying to solve tan x is equal to negative 2/3. And you'll know from when we did trig that I tell you to always sketch a graph. So let's draw the tan graph really fast. Where's my pen gone? Okay, so here's the tan graph here. And we want values between 0 and 360 degrees. So we're going to put a line in here at negative 2/3, and we can see where those solutions should be. Right now, you don't have to do that. I know that you're probably going to go, oh, we can go faster if we don't do that, but it is going to help you get better at avoiding small mistakes. Chucking this into your calculator will give you straight away that the first value of x is 146.3 degrees, and the second value of x is really easy for a tan graph. We're just going to add on one period, and we get, which is 180, and we get x is equal to 326.3 degrees. Right, so that was the sort of straightforward 3 marks of the question. Next, we have to sketch the graphs of this and this. So this is going to link back up to what we did here. And they're reasonably forgiving with how you sketch those graphs, but I'm going to show you what I'd like you to do when you're doing a graph sketch. If you're asked to do it in a test. I want to see some nice x and y values, and I'd also really like it if you could use a ruler so that you get your amplitudes reasonably accurate. So we're going to be drawing y equals 2 cos x, so I'm going to mark off here 2 and 3. So here's 1, just one little dot there. Let me move the ruler. 1 here and 2 here. Good enough. So it doesn't have to be absolutely accurate, but it will help you. So we're going to go down to negative 2 there. And for negative 3 sine x, we need to have an amplitude going up and down to 3 and negative 3. Right, so first of all, y equals 2 cos x is just a cosine graph with a vertical stretch. So it's going to start here, and I'm going to sketch that on now, and I'm going to do that before I put my values down for degrees. So that'll do. Now let's mark in where this is. So this is at 90 degrees, and that's not quite low enough, but it'll do. Okay, there we go. So there's 180 there, and here we've got 360 here. Now what about negative 3 sine x? Well, 3 sine x would just be a vertically stretched sine x, but it's also going to be reflected. So sine of x starts at 0, but instead of heading upwards, it's going to go downwards, and it will hit negative 3 when it's down here at 90 degrees. It's going to cross through here, and then it's going to go up to here. I'm going to do this one in a different color. We'll do this orange. there. Okay, so it's a bit dodgy. In fact, it looks terrible, but that's your -3 sine x graph. Things that we should have here, we should have an x here, and we should have a y here, and we should label our two graphs. So that's my cosine one there, and that's my sine one there. The next thing you're asked to do once you've drawn those graphs is to use your answers to part 1 and 2 to find the set of values for which this thing here is strictly positive. So 2 cos x is greater than -3 sine x. So if we've drawn our graph well, this is going to be very easy. We can see the regions in here. We want the cosine graph being bigger, so everywhere in here it's going to be bigger, and then it's going to happen again just at the very end. So the answer here is from the graph, and knowing what the values of these points are, it's going to be when x is between 0 and 146.3 degrees, and when x is greater than 326.3 degrees. Now, I was asked for when it's strictly greater than, so I'm just going to tweak that, and that should be here. It should be a strict inequality there. All right, so that's enough for one video. Please just shoot me an email if you've got any questions on those. I'll do some of the coordinate geometry ones later on today.